Hey everybody, Archie Bunker here, and this is a review of Chapter 12. Let's begin. Okay, the level C confidence interval for your population proportion is p hat plus or minus your z star and the square root of p hat 1 minus p hat all over n, where p hat is your sample proportion and your z star is your normal critical value, what you get on table C. Okay, and then to test for hypotheses testing, you test your null hypotheses is your population proportion equal to your proportion that you're testing right here, uh, and that they're based on these statistics here. So p hat minus your proportion you're testing and the square root of it looks all similar. Doesn't this look similar to this up here, you guys? This square root right there, it's all the same. With p-values calculated from the standard normal curve, so we get our z-table statistics, table A. So the inference procedures are approximately correct when the population is at least 10 times as large as the sample, and n times your sample proportion greater than or equal to 10, and n times the complement is also greater than or equal to 10 for a confidence interval, or n times your proportion you're dealing with is greater than or equal to 10, or n times that complement is also greater than or equal to 10. Okay, and that's when you're testing the hypotheses that the population proportion equals whatever proportion you're talking about. All right, the sample size needed to obtain a confidence interval with approximate margin of error. You solve this equation, remember that? Okay, and so this is my margin of error right here that we want to get it into. And look, isn't this all the same as the other ones, that square root thing? It's all the same, you guys. All right, for n, your p stars is a guessed value for the sample proportion p. Sam, and your z star is the same z star that we're dealing with. Okay, so and remember, if they don't give you that percentage in there, then you assume it's going to be 0.5. Okay, and you'll expect that your true p hat will be roughly between the 0.3 and 0.7 when you plug in 0.5. They're going to ask you to do that in 12.15. So all right, so an experiment on the side effects of pain relievers assigns arthritis patients to one of several over-the-counter pain medications. If 440 patients who took a brand of pain reliever, 23 suffered adverse symptoms. Okay, does this experiment provide strong enough evidence that fewer than 10% of patients, there's our p sub 0, who take this medication have adverse symptoms? Okay, so step one, we're interested in the patients treated with arthritis medication of 440 patients. Okay, and so my null hypotheses, what I said is that 10%, and then my alternative hypotheses is less than that 10%. And here's my sample p right here. Okay, and we're going to calculate that in just a second. I think that's on the next click. Our parameter of interest is the patients with adverse symptoms. Okay, so here's our checklist. We've got to check off all these conditions are met. So the population is at least 10 times the sample, obviously. And those conditions are met your proportion times your sample size is greater than or equal to 10. And the complement times the sample size is also greater than or equal to 10. Also, we're not sure if it's an SRS, but it appears to be, so we're going to go ahead and proceed with some caution. It's always safe to say that. And then the calculations, here we go. And here goes our fun mix. So we're going to plug in my p hat, and this 10% goes right here, and then it's going to be, there we go. Okay, makes sense, and it calculates to that, and you get negative 0.337. So if you looked up negative 0.33 on the p-values in table A, you get 0.0004, and you get the same for negative 0.34. So that's it's 0.0004, which is much less than 5%, which is 0.05. You guys, some of you guys have struggles remembering what 5% means. It's 0.05. So interpret our results. Therefore, we have strong enough evidence, very strong, against HO and in favor of your alternative hypotheses. So we can conclude that fewer than 10% of the patients who take this medication will have adverse symptoms. Okay, PTC, I was not aware of this until I started reading out of this book, is a substance that has a strong bitter taste for some and is tasteless for others. It's tasteless for me. The ability to taste PTC is inherited. About 75% of Italians can taste PTC, for example. So you want to estimate the proportion of Americans with at least one Italian grandparent who can taste PTC. Okay, let's see. So starting with 75%, with the 75% estimate for the Italians. Okay, now that's that 50%. If they didn't give it to you, then we'd use it. But this is 75%, so we're going to use that formula. Starting with the 75% estimate for the Italians, how large a sample must you test in order to estimate the proportion of PTC tasters with a margin of error plus or minus 0.04 and a 95% confidence? Okay, so here's the 75%. It goes right here, so 25% is going to go right there. 95% is going to be your Z star is 1.960 from table C, and your 0.04 is going to go right there, and you're going to solve for n. Okay, we want to know the sample size, so here we go. We get n is greater than or equal to 450, so you get 451 Italians. Okay, and there's the homework right there.